Hi, this is Jonathon Gerding.
Trever Vogel.
Michael Dzurnak.
And during this lab, we set out to calibrate an ultrasonic distance sensor to determine its static and dynamic attributes. This sensor works by projecting 13 42 kHz pulses and waits for the pulses to reflect back from an object. It then uses the time from when the pulse was sent to when it was received, along with the assumption of standard atmospheric parameters, to determine the distance between the sensor and the object. The sensor records this distance as an analog voltage and sends it to a buffer, then adjusts its output from the previous value to the current value in the buffer. This process occurs over approximately 50 milliseconds and repeats after each cycle. We wired our sensor according to its provided datasheet, with the analog output being fed into our DAC as well as a known good voltmeter for verification of what lab view recorded. The target object was a 9x9 inch box. The box was placed 14 inches in front of the sensor at startup in accordance with the datasheet's recommendation. On startup, the sensor does its own calibration, and it is recommended that an object not be within 14 inches during this process. Our static calibration consisted of several static distance measurements from 14 inches to 110 inches. The dynamic calibration involved a step input from 14 inches to 79 inches, provided by our target box being quickly removed from the view of the sensor, making the sensor then measure the distance to a far wall. Our static calibration data was taken at 5-inch increments, starting from 14 inches, moving up to 110 inches, then moving back down to 14 inches. We assumed that because the sensor is digital with a buffer, that there would be no hysteresis error, and our results confirm this. We used these points to find the static sensitivity of the sensor over this range, the R-squared value of our linear fit, the linearity error, and zero drift error. Our dynamic calibrations results show how a digital sensor such as this can be modeled as a zeroth order system. As this sensor operates on a 50 millisecond cycle and only adjusts its analog output during the last 5 milliseconds of the cycle, the time constant found was that of the analog voltage adjustment circuitry, and thus has no meaningful relationship to the overall bandwidth of the sensor. Rather, the bandwidth of this sensor is determined by the cycle time alone. From these calibrations, we found the static sensitivity to be 0.0236 volts per inch over the tested range, but we expect this sensitivity to hold over the maximum range of the sensor as it appears to be very linear. The found time constant for the analog adjustment circuitry is interesting but not relevant to the sensor's bandwidth, which is 20 Hz, or the inverse of its cycle time. Thank you.